Welcome back, Titans. We're here with episode 7 of your Algebra 2 flipped classroom. We're looking at section 13.1 today. It is something you've already seen, especially in geometry, right triangle trigonometry. And we're going to use those right triangle trigonometry to solve right triangles. So let's jump right in here. Now, we got to develop these right triangle definitions first off. So what we're going to do is we're going to create a right triangle. And I can't write in white pen. I've got to pick a different color. We'll go red. So a right triangle, remember, has a right angle. We're going to label all the angles, so let's just call them A, B, and C. Angles A, B, and C. Notice the angles are all in capital letters. Well, opposite those angles are going to be the sides, and the opposite angle is going to be the same letter but lowercase when we name these. This is just our base right triangle. Angle A is over here, opposite side is little a. Angle B is over here, opposite side is little b. Angle C is the right angle, opposite side, which we call the hypotenuse, is little c. Okay, so that's our basic right triangle. We'll use quite a bit, we'll work with. The opposite side is the same letter, but lowercase. Alright. Moving on here. So, let's look at a right triangle again. Let me draw that right triangle back in here. So, we've got a right triangle. Angles A, angles B, and angles C. And turns out what we have is we've got 6 trig functions. The 3 you know, you use all the time, not all the time, but probably you've used before, are sine, cosine, and tangent. And the 3 you don't know are what we call cosecant, secant, and cotangent. Well, the sine from SOHCAHTOA, if you don't remember SOHCAHTOA, it's your shortcut. Okay, it's your shortcut. So stands for sine. The S, okay, is sine, stands for opposite over hypotenuse. The cosine is your ka, stands for adjacent over hypotenuse. And the TOA is your tangent, which stands for opposite over adjacent. And you're just looking at those sides. It's a fraction for what the sides are. Cosecant, now, is actually the exact opposite. It's just the reciprocal of the sine. We flip it. For cosecant, we do hypotenuse over opposite. For secant, we do the opposite of cosine. It's hypotenuse over adjacent. And for cotangent, it's the opposite of tangent. It's adjacent over opposite. So if you remember SOHCAHTOA, and you remember the first 3, sine, cosine, and tangent, you automatically know cosecant, secant, and cotangent. It's just about knowing which one goes with which. So make sure you pause right now, you write this stuff down, make sure you get SOHCAHTOA down in your notes. Hopefully you're taking some notes while you watch this. This stuff right here is going to help you out. It's going to be very, very important for you. Okay, so moving on here, finding trig functions of acute angles. So what we're going to do here is we're actually going to find, we've got an example here, angle or triangle ABC, and we want to find the 6 trig functions. Well, I want to find all compared to angle A. So what I'll do with angle A here is I will label all my sides compared to angle A. Well, compared to angle A, the opposite side, I'm in my triangle here, the opposite side is 20. So I'm going to label this one O. The hypotenuse is always across from the right angle, so I'm going to label that one H. 52 is H. And then that leaves my adjacent. Adjacent kind of means right next to, so the one right next to A here is 48. So opposite is 20, adjacent 48, and hypotenuse is 42. So when I go to find my 6 trig functions, the sine of A, remember sine, so means opposite over hypotenuse, is going to be what I say O was, 20, over hypotenuse 52. Okay, cosine, adjacent over hypotenuse. What did I label as A? 48. And what did I label as H, my hypotenuse? 52. And then tangent, opposite over adjacent. Well, what did I label as opposite? 20, and adjacent 48. And I'll let you go ahead. You really want to go ahead and simplify those. I'll let you do those on your own though. Okay, so now I found the first three, sine, cosine, and tangent. Now I need to find the other three. Well, again, if you remember from the slide before, hopefully you wrote that down, and you're writing this example down, the cosecant of A is just the exact opposite. It's 52 over 20. The cosine, the opposite of cosine, was the secant of A. I just flipped the cosine, 52 over 48. And the tangent is opposite over adjacent, so that means the cotangent is the exact opposite. I just flip it. It's 48 over 20. And now I've found the 6 trig functions. And you might be asking, why do I need these? This will come in a little later on in class tomorrow or in the next sections on what we do with these. But these are just your trig functions, and find the 6 values of those trig functions for this triangle. And notice they are all compared to A right now. Okay, everything's compared to A. Alright. There are our 6 trig functions. Let me simplify those there right there. Now also don't forget about the Pythagorean theorem. The Pythagorean theorem here is a squared plus b squared equals c squared when you're talking about the sides of a right triangle. Sides of the right triangle. You take the legs, square them, and add them together. And that should equal the hypotenuse, remember this is the hypotenuse, squared. Okay? That is the Pythagorean theorem. So now let's look at some special triangles. And first we're going to look at an equilateral triangle. And equilateral triangles, they have all 3 equal angles. And each measures 60 degrees. All equal triangles are similar too. So I have one with all sides being 2. Because if all the angles are the same, all the sides are the same, I can draw another one here and say these are all 60 degrees. Well, then if one side's 3, they all got to be 3. Or I could draw a really, really big one. This is not to scale, but let's pretend this is to scale. And they're all 60 degrees here, and say this side was 100. Well, then that would make the rest of the sides 100. So that's what that means by proportional, or they are similar. Well, what we can do is we can cut that in half actually, and we can create this little right triangle here. And I'm just cutting 2 in half. I get 1. This side stays the same right there as 2. And then I found this side right here using the Pythagorean theorem and square root of 3. So I got the sides of this 30, 60, 90 triangle it turned out to be. 30, 60, 90. Turned out they were 1, the square root of 3, and the hypotenuse was 2. So I just cut this first triangle in half, cut that 60 degree angle right here, made it 30 degrees, and the rest was 60, and the other one was 60, and found out they were 1, the square root of 3, and 2. Well, when I look at a 30, 60, 90 triangle, I'm just using the same one before, 1, square root of 3, and 2, I can find some actual square roots here, or some actual cosines, tangent, and sines. That turns out the cosine of 60, so when I'm looking at 60 here, the adjacent side is 1, the hypotenuse is 2, so the cosine is 1 over 2. When I look at the tangent is opposite over adjacent. Well, my opposite side is square root of 3, my adjacent side is 1, so this is really the square root of 3 over 1. So I could use this special right triangle to find these for me. And then the other one, I'm looking for the sine of 30. Well, now I'm looking at 30 degrees. Compared to 30, 1 is opposite and 2 is the hypotenuse. So 1/2 is the sine of 30. And this special right triangle works for multiple right triangles. I can draw several of these. Doesn't just have to be this one. Like what I could do is draw another right triangle, special right triangle, say this is 30, 60, 90. If this is 2, then this is 2 square roots of 3, and this one's, the hypotenuse is just doubled. I could draw another one, right triangle here, 30, 60, 90. The short side down here, if it was 4, then the side opposite of 60 would be 4 square roots of 3, and the hypotenuse would be 8. We just double the short side. Okay, and that pattern holds for any 30, 60, 90. We also have a 45, 45, 90. The sides of a 45, 45, 90 are 1, 1, and the square root of 2. That holds for all of these as well. So if I have another 45, 45, 90, let's say one side is 2, then the other side is 2. They are always the same because they're the same angles that they're opposite of. And then this would be 2 square roots of 2. If I had a different one where this was 3, 3, then the hypotenuse is 3 square roots of 3. So hopefully you can notice a pattern there. The legs are the same and the hypotenuse is always the leg times the square root of 2. Okay, so those are some special right triangles. I can use this special right triangle here to find the cosine, the tangent, and the sine of 45, just based off my triangle, where one would be opposite, one would be adjacent, and square root of 2 would be the hypotenuse. And I plug those in and find these 3 values. So those are our special right triangles. Now let's look at an example here. I want to find the value of each of the 6 trig functions of the angle theta. Well, they gave me 12 and 13, so I need to find this last side, which is adjacent. 12 is opposite, 13 is hypotenuse. I need to find that last side. So what I'll do is I will use the Pythagorean theorem, a squared plus b squared equals c squared. And when I plug that all in, I get a equals 5. Okay, so use the Pythagorean theorem to find that third side. So now looking at that third side, I've got my theta right here. The side opposite is 12. The hypotenuse is 13 because it's opposite the right angle, so that makes 5 my adjacent. So now when I'm finding the sine of theta, remember sine is opposite over hypotenuse, so it's 12 over 13. Cosine is adjacent, 5 over hypotenuse, 13, so katoa. And tangent is opposite, 12 over adjacent, 5. There are my 3 trig functions. I need to find the other ones. I've got the cosecant of theta, just flip this, 13 over 12. I've got the secant of theta, just flip this cosine, 13 over 5. And I've got the cotangent of theta, 5 over 12. There are my 6 trig functions. Okay, find that third side using Pythagorean theorem and then label your sides and plug them in. Alright, last example here. Go ahead, see if you can find this one on your own. You've got this right triangle. Go ahead, pause. See if you can find this third side up here, which is the hypotenuse, and solve. Go ahead, pause. And now we're back. Hopefully you found the hypotenuse to be 15. So we're comparing it to theta here. 12 is my opposite, 9 is my adjacent, and 15 is the hypotenuse. So I go ahead and plug those in. I get 12 fifteenths, cosine 9 over 15, tangent 12 over 9. And again, I would simplify these: 4 fifths, 3 fifths, and 4 thirds. Then when I find the other ones, the cosecant, secant, and cotangent, I just flip it. 5 fourths, 5 thirds, and 3 fourths. And we are finished. So finding these trig functions today is the key. And that is actually the end of episode 7. We're going to learn how to use our calculator to find some of these sides and trig functions in class tomorrow. So be ready to rock and roll. If you got to rewatch any of this, rewatch it. It should be a lot of review from geometry, but we threw in a couple new trig functions possibly. So have an awesome evening, and we will see you tomorrow. By the way, no music tonight. Trying to keep it just video.